Have you ever wished to jump into the future or slide back into the past? An intriguing proposition, isn't it? This is the enigma of time travel, a concept that has fascinated us for centuries, transcending the boundary of imagination into the realm of scientific exploration. The idea of time travel wasn't always serious science. It originated in the imaginative works of science fiction, where authors like H.G. Wells stirred the public's imagination with tales of time machines and journeys into the future. But, as the saying goes, sometimes truth is stranger than fiction. Over the past century, time travel has transitioned from the pages of novels into the equations of theoretical physics. Now, to understand time travel, we must first grasp the nature of time itself. You see, time isn't just a ticking clock or a turning calendar page. According to physicists, time is a dimension, akin to the three spatial dimensions we're familiar with: width, height, and depth. This theory, known as space-time, was proposed by none other than Albert Einstein in his groundbreaking theory of relativity. In this four-dimensional model, time and space are interwoven into a single continuum. Imagine a cube. You can move up or down, left or right, forward or backward. Those are your three spatial dimensions. But there's a fourth direction you're moving in as well, whether you realize it or not. That direction is time, and you're moving forward in it, second by second. But here's the catch. While we can freely move in the three spatial dimensions, our movement in the dimension of time is rather limited. We are perpetually moving forward from one moment to the next, bound by the inexorable march of time. This takes us back to the original question. If time is just another dimension, one we're constantly moving in, then why can't we move freely in it? Why can't we go back to relive the past, or leap forward to explore the future? So if we can move freely in three dimensions, why not the fourth one? Time. But how does time travel work from a scientific perspective? Well, the cornerstone of understanding time travel lies in the theory of relativity, proposed by one of history's greatest minds, Albert Einstein. In a nutshell, the theory of relativity tells us that space and time are not separate entities, but are instead intertwined into a four-dimensional fabric known as space-time. Now, this space-time isn't rigid, it's flexible, and can be distorted by mass and energy. Picture it like a trampoline with a heavy ball in the middle. The ball represents a massive object, like a star or planet, and it causes the trampoline to dip, creating a curve. This curve is what we call gravity. But what does this have to do with time travel? Well, Einstein's theory also tells us that the presence of mass and energy can warp not just space, but time itself. This is known as time dilation. Here's where it gets interesting. According to this concept, time can move slower in areas of higher gravity or at extreme speeds. So, theoretically, if you were to orbit a supermassive black hole or travel near the speed of light, when you return to Earth, you'd find that more time had passed here than for you. In a way, you'd have traveled into the future. But what about going back in time? Well, that's where wormholes come into play. Wormholes are theoretical tunnels or shortcuts through space-time, predicted by the theory of relativity. If it were possible to traverse a wormhole, it could potentially provide a pathway, not just to distant parts of the universe, but also to different times. However, it's crucial to remember that this is all theoretical. While the mathematics of Einstein's theory allows for time dilation and wormholes, we have yet to observe or create these phenomena in a way that would enable time travel. In essence, time travel is not about moving through space, but rather bending it. Time travel, as science currently understands it, is less about jumping into a time machine and more about manipulating the very fabric of reality itself. But what happens when we meddle with time? Well, time travel, as intriguing as it sounds, brings along with it a suitcase of paradoxes. Paradoxes are situations that defy logic or intuition. In the realm of time travel, two of the most famous paradoxes are the grandfather paradox and the bootstrap paradox. Let's start with the grandfather paradox. Imagine, for a moment, that you've built a time machine. You travel back in time and meet your young grandfather before he has any children. Now, what happens if you prevent him from meeting your grandmother? Logically, your parents, and by extension you, should never have been born. But if you were never born, then who traveled back in time to disrupt your grandparents' meeting? Onto the bootstrap paradox, which takes its name from the phrase, pulling yourself up by your bootstraps. This paradox involves an object or piece of information sent back in time, which becomes trapped within an infinite cause-effect loop. Imagine you're a scientist who receives a detailed blueprint of a time machine from your future self. You build the time machine based on these blueprints, then later send the blueprints back to your past self. The conundrum here is, who actually created the blueprint? Each of these paradoxes presents a unique problem. They suggest situations where cause and effect become circular, creating infinite loops that challenge our understanding of causality. The grandfather paradox questions the consistency of historical events, while the bootstrap paradox challenges the very notion of originality and creation. These paradoxes aren't just mind-bending puzzles. They also raise serious questions about the nature of time and the universe. They represent the clash between our intuitions about the world and the strange implications of time travel. So the next time you daydream about hopping into a time machine, remember, it's not just about the thrill of seeing dinosaurs or the future. It's also about facing and understanding these paradoxes, which pose serious challenges to the feasibility of time travel. Time travel has captured the imagination of many, hasn't it? It is a concept that has been embraced by creators across different mediums, serving as a springboard for countless stories that have captivated audiences worldwide. Take, for instance, the cinematic universe. One of the most recognized and beloved time travel films is Back to the Future. This trilogy, with its iconic DeLorean, not only brought time travel to the mainstream, but also emphasized the butterfly effect, showing how even the smallest actions in the past can drastically alter the future. In the realm of literature, H.G. Wells' The Time Machine is a classic. Published in 1895, it introduced readers to the concept of a vehicle that could move through time. It painted a grim picture of the future, exploring themes like class struggle and the consequences of unchecked technological advancement. On the small screen, Doctor Who has been exploring the cosmos and the timeline since the 1960s. The show's time-traveling protagonist, the Doctor, uses a TARDIS, a time machine that can camouflage itself into any environment to navigate through time and space, often meddling with historical events and battling extraterrestrial foes. These stories, and many more like them, have used time travel as a plot device to create compelling narratives. They've allowed us to ponder ethical dilemmas, question the nature of fate, and explore the intricate tapestry of cause and effect. They've taken us to the far reaches of the future and the distant past, showing that the concept of time is as flexible and as infinite as our imagination. It's fascinating to see how these narratives play with time, often bending and twisting it to suit their stories. They've explored the consequences of altering the past, the dangers of knowing the future, and the complexities of living outside the linear progression of time. These stories often play with the concept of time travel in inventive and fascinating ways. They remind us that while we may not be able to hop into a DeLorean or a TARDIS just yet, we can always journey through time in the pages of a book or the frames of a film. What if time travel becomes a reality? This question opens up a floodgate of possibilities and implications that are as fascinating as they are complex. Imagine, for a moment, the potential benefits of time travel. Scientists could study events from the past or future firsthand, gaining insights that would otherwise be impossible. Historians could witness important events unfold, verifying or challenging our understanding of the past. We could even find uses in fields as diverse as archaeology, where time travel could reveal the secrets of ancient civilizations, or medicine, where doctors could observe the progression of diseases over time. But with these incredible possibilities comes some serious concerns. The implications of time travel extend far beyond the realms of science and history, into the territory of ethics and morality. If we could alter events in the past, should we? Could we justify changing history to prevent wars, disasters, or personal tragedies, even if it means erasing the lessons we've learned from those events? And who gets to decide what changes are made? These questions present profound moral and ethical dilemmas that society would need to confront. Furthermore, there's the risk of creating temporal paradoxes, scenarios in which our actions in the past could negate the very reason we traveled back in time in the first place. This could potentially result in unpredictable and potentially catastrophic consequences. Then, there's the question of access. Who gets to use this incredible power? Would it be limited to scientists and historians, or could anyone with enough resources take a personal trip through time? The potential for misuse and manipulation is staggering, and regulations would need to be carefully considered and enforced. Time travel, thus, is not just a scientific concept, but a philosophical and ethical conundrum as well. It forces us to confront challenging questions about causality, responsibility, and the very nature of reality itself. Whether we ever achieve time travel or not, the exploration of these possibilities and implications can still provide valuable insights into our understanding of time, history, and our place in the universe. So, can we ever travel through time? We've delved into the enigma, the science, the paradoxes, and even the pop culture surrounding time travel. Theoretically, it's not off the table, but the practical hurdles and paradoxes are as vast as time itself, making it a complex subject indeed. We've also explored the possible implications and opportunities that time travel could offer. Whether we can ever conquer time remains to be seen. Until then, it will continue to fascinate us as one of the greatest mysteries of the universe.